Hello everyone, welcome back. Today we are diving into one of the most fascinating mathematical sequences, Fibonacci sequence. So we'll be discussing the rabbit problem with that mathematical sequence. The story begins like this. Assume that in the rabbit problem, a pair of rabbits, male and female, are placed on an island. No other rabbits can come. Rabbits reach reproductive maturity after 1 month. Each mature pair can produces a new pair every month. Their pregnancy period is 1 month, and of course, rabbits can never die. So our goal and the problem is we need to find out how many pairs of rabbits are there at the end of 12 months after a year. So let's solve that problem using Fibonacci sequence.
Now, what is the solution? So let's determine at the beginning of the first month, there is only one young rabbit in the island. As you can see here, there's only one young rabbit. And now let's go to the beginning of the second month. In the beginning of the second month, since 1 month has passed, this pair of baby rabbits become reproductive rabbits and they become adults. As you can see, still there is one player at the beginning of the second month. So at the beginning of the third month, this pair produces an offspring and they remain there. Therefore, total number of rabbit pairs are 2. Now let's move on to the fourth month. In fourth month, this adult rabbit prepares another offspring, and this previous offspring is become into an adult. So in the fourth month, there are total of 3 rabbit pairs. Now let's move to the fifth month. In the fifth month, this adult rabbit produces another offspring, and this previously made offspring becomes an adult, and this adult prepares another offspring. Therefore, total number of rabbit pairs are 5. Now let's move to the sixth month. In the sixth month, as before, adult rabbits produces offspring while young rabbits becomes adult. Therefore, in the sixth month, the total number of rabbit pairs are 8. Likewise, we can determine number of rabbits from here. If we look closely in the number pattern, we can see that this is a Fibonacci sequence. We can obtain the Fibonacci sequence number by adding the previous 2 elements. In here, you can see 2 is obtained by 1 plus 1. And 1 plus 2 is 3. And after that, 2 plus 3 is 5. And after that, 3 plus 5 is 6. Likewise, we can determine the entire Fibonacci sequence by using this pattern. As you can see here, at the beginning of the 12th month, 144 rabbit pairs are produced. But is that the answer that we want? No. We need the number of rabbits after 12 months, not in the beginning of the 12th month. So, we need to calculate up to the 13th beginning month. So, let's add the Fibonacci sequence once more. And the total number of rabbit pairs after 1 year on an island is 233. Now that is our answer. Now let's discuss how to solve this rabbit problem using manual application of recursion. So let's discuss how many pairs of rabbits will there be after 1 year. So we need to find the Fibonacci number 12. Since we discussed earlier, a Fibonacci number is the addition of previous 2 Fibonacci numbers. Therefore, Fibonacci 12 is equal to Fibonacci 11 addition to Fibonacci 10. And Fibonacci 11 is equal to Fibonacci 10 addition to Fibonacci 9. And with that, we have another Fibonacci 10 derived from here. Therefore, there are 2 Fibonacci 10. Therefore, we put 2 as common multiplier for Fibonacci 10 and plus 9. Then, this plus 9 is equal to this 10 is equal to Fibonacci 9 plus Fibonacci 8. As like that, the same pattern goes over and over again until we get to the last point we derive the last Fibonacci number and we get the answer 233. Therefore, so the number of rabbits after 12 months is 233 pairs of rabbits. Now let's move to the coding part. Okay. Now let's implement the Java code for Fibonacci sequence using iterative approach and the recursive approach. First, we will be discussing about the recursive approach, then we will go into the iterative approach. Now, as you can see here, I have written the Fibonacci recursive approach in this code. If you can see clearly, I have created base case. If the n is the input, it returns 0, and another base case, if the n equal 1 is the input, it returns 1. Then the other is return Fibonacci function, which recursive calls. And as you can see here, this is the main function, and I have written this code so that it outputs the value of the 10th Fibonacci number. If we change this value, it outputs the relevant entered value, and from by here it prints the Fibonacci number and the Fibonacci value. Let's see how this codes work. If we input, if the n value is equal to 1 or 0, it returns the same base value. If 0 is entered, 0 is returned. If 1 is entered, 1 is returned. Otherwise, we call the Fibonacci function. It's not a function. Because you call the Fibonacci n-1 plus n-2 until it reaches the base case. Now, let's run this code and determine whether this code works or not. As you can see, it has given us an output. The 10th Fibonacci number is 55. So it gives the correct answer, but there's a problem with this code. The problem is this code is not efficient because this code calls many unnecessary calls. This code has become inefficient, and this code does many unnecessary calculations also. Therefore, we consider this code as an inefficient and energy consuming and memory consuming code. So what is the solution for this? We can use an alternative method. Therefore, we can use the Fibonacci iterative approach for this function. As you can see here, I have created the code for that also. If n is 1, it returns 1. If n is 0, it returns 0. And there's the for loop, as you can see, and it returns the sum. As you can see here, in the main function, this also searches the value for the 10th Fibonacci number and outputs that in an SOUT statement. Now let's run this code and determine that. So we ran the code and the output is the same. The 10th Fibonacci number is 55. So this is an inefficient. This is not an inefficient code. This is an efficient code. Why do we consider this an efficient code? Because this code uses a loop instead of recursion to avoid unnecessary calls. Now that's all for the coding part.
Now we know how to solve the rabbit problem using Fibonacci sequence. So what are the real-world applications of this? First, computer science. In computer science, for data structures, algorithm and dynamic programming, Fibonacci sequence is used. In stock market, traders use Fibonacci sequence to predict future price movements. In biology, in DNA and many sorts of plants, Fibonacci sequence is used. Today we learned about the rabbit problem and how it leads to Fibonacci sequence and how to implement it using Java and the real world applications of it. If you want more videos like this, please make sure to like and subscribe. Thanks for watching. See you in the next video. Hey everyone.